Okay, so where are we at? What happened?
We left on delete ads, right? Again.
Okay.
But I tried making like delete node, but I didn't know how to like get into it.
Okay. So I recommend writing the test first, as always. So yeah, it's now more important than ever that you start writing the test first because
Okay, okay.
that gives you an understanding of the behavior. And right now, behavior is complicated due to mutation. So let's start with the test.
Uh, okay, okay, of course. So mm, I can just start off with like that. Mm,
Nice, the simplest case. Very good.
right, right. Uh, and then mm,
I also recommend n empty and zero. I think that's a pretty good case as well.
okay,
That's like
so I
a
can
razor edge, right? Razor edge case.
yeah, yeah.
Like
It's
like
like
what they use in a barber. Yeah.
yeah, yeah. And then like deleting the first element, right?
Yeah.
Mm, so like I can just copy that.
Okay.
It will be easier, I think. So mm, no, no, because it's not. Yeah, is it? Yeah. Wait a second. Wait a second. Sorry, my mom just.
Oh, I can pause the recording if you need.
No, no, no. It's
Okay.
okay. It's okay. I'm
All right.
back. Okay.
Oh, okay, that was fast. All right.
Yeah.
Usually when my
Uh,
mom calls me, I'm gone for 2 hours.
really? Okay. That's too bad.
Yeah.
Uh, so not that. Delete nodes at node one. Mm, and then zero should return like node two, right?
Okay.
Mm, okay.
Actually,
And
wait, before we move forward, can you tell me what's delete node doing? Like in words. Can you give this a purpose statement on line 485?
uh, yeah. Mm, wait. I need to like think about it. How
That's
to
good.
say it? Mm, yes. Mm, yeah. So like we are trying to find like index that we are like the given index, right? And we are trying to like jump or over it in like our memory, right? So like we are trying to avoid that index, right?
Yeah. You're referring
Mm,
to the moving of the arrows in the box and arrow diagram, right?
yeah, yeah, right, yeah.
Okay. So yeah, okay. Can you still explain in words how you want that to happen with delete node?
Uh, so if like the index is zero, right? We just return the uh, the rest of the wait. Mm. Yeah, we return the rest, right?
Okay, so can you write that down as a purpose statement on line 45? This is the second step of the design recipe.
Yeah, like, mm, how to like put it in words? Can I like write what it does? So like,
Yes, yes, exactly.
okay, uh, okay, so it like, okay, so if it's a valid index, it like, uh, like call itself with, uh, mm,
This is hmm. Okay, interesting approach.
okay,
Okay, sure. Yeah, let's try this. I've never done it this way, but I'm not sure it will work. But let's try it.
okay,
This will be my first time seeing it.
okay,
Oh, can you have one more test case where it's not this
of
index is
course,
not zero,
yeah,
so it's
that
valid and the
is
index is not zero.
that is like reasonable, right?
Yeah, yeah. So couple all cases, right?
Right. Uh, and I don't know, one is, what it will be, uh, uh, oh, we cannot like do it like this, right? Unless like, um, why are there so much indentations? I don't know. Okay.
Whenever you don't close an if, so on line
Oh,
494, it
right,
will.
right,
Yeah,
right.
there we
Okay, I
go.
can do.
Now that one should be fixed. So
makes
broken
sense.
indentation usually means that you didn't close something.
Okay, so it's like value should be one. Uh, its value is three, right? Are the tests correct?
Well, careful. Line 504, you're deleting a node as well, right?
Right. So
When you delete node 1, are you doing anything to node, like, so line 504, when node 1 is deleted, is node 1 changed in any way? Oh no.
uh, when node one is deleted, right?
Yeah, so
It's
line 504, when you delete node 1,
hmm,
is node 1 mutated? Or just
hmm.
nothing happens to it?
Wait. No, nothing happens to it, right?
No. Yeah, I'm asking you, does something happen to it or nothing happens to it?
No, I think that nothing happens, right?
Okay. There are, both are valid. You could cut it from the rest of the list. You could also do nothing
Yeah,
to it.
yeah,
But you're choosing to do nothing, just nothing.
yeah.
Okay, no, that's
Mm.
fine. Um, as long that we're clear on that. Oh yeah, you made end node one. Okay, so
Of
there's
course.
no ambiguity. So the tests don't actually impact each other. Okay, sure.
So so yeah.
Okay.
Uh, the tests are done, I think.
Okay, sure. Yeah. Okay,
Mm,
let's move on to the delete. Okay. One thing I
yeah,
can we go back to delete at line 518? Are we good with this? Before we move on to finishing the body, I just want to make sure that line 519 is good. We are confident with this.
mm, I think so.
Okay,
Like,
so whenever you have a helper function, I like to make sure that whoever is using a helper function is using it correctly first. Because if you spend all the time working on a helper function and helper function is wrong, you waste all that time, right?
yeah, right.
Okay,
Yeah, makes sense.
okay,
Okay, so it
let's do
should be
it.
like, mm, and the rest we delete node of uh, and I minus one.
Okay,
Please work. Of course it doesn't. Yeah.
let's see. Unexpected error was not satisfied. What is this? Oh, wait. Is it what I think it is?
Pirate hates me.
And node, delete node.
Even like delete add has errors.
Oh, did we use? I think there's a naming conflict or something. Did we use NMP before?
Mm, I don't think so. No.
And
Definitely
link.
not.
The only way I can see this causing problems is we use some name before. No, and
No,
link is new. Hmm.
like
Is
yeah.
note taken? let me check the prior documentation. It's known
Yeah, of course.
oh, you got me stumped,
Yeah, that's the reason we must like go to C++.
dude. If the error messages stump you right here, C++ is a lot worse, man.
I know, right?
Why is it not satisfied? They're all numbers. oh, there is a bug. I don't know if this is what's causing your problem, but 509, 510,
Uh,
it should link to end node.
okay.
Yeah,
I don't think that is like
yeah.
yeah,
It's not it.
that
Okay.
wasn't the problem.
Let me think about it. Oh, wait a minute. I think I know why. No, no, I don't know why. Never mind.
Okay, okay.
Sorry, I got your hopes up.
This is what like programmers were before AI, like
Yeah.
figuring the bugs.
Okay, wait, I'm gonna start modifying your code.
Mm. And it doesn't change anything.
Delete. Wait a minute. Oh, delete. Um, this keeps us back. Oh, I think I know why. I think I know why.
No way.
Do you see what I did?
Yeah.
Oh fuck, never mind. Sorry. I got your
Sorry,
hopes
sorry.
up.
Yeah, you had me for a second.
Oh, I thought that was it.
Yeah.
I'm just gonna do some random stuff.
No problem. Fine with me.
Oh, honestly, not gonna lie, I really thought it would be that. Oh, if it's not an exclamation R, it's an exclamation rest.
Hmm. Okay.
I suspect it's the cases that's messing us up, so I'm purposely not using anything provided by the case. Yeah, yeah, okay. So I got it to not error out. I think I need to do more research. There's something about the cases mutation that I'm not understanding.
Okay.
Wait, I'm gonna copy your file to my file system.
Hmm.
Okay. I'm gonna explore this later. All right. So don't use like 490, the VNR, don't use those for now. I'm sorry. Your code will look uglier, but I don't know what's up with this. I need to investigate.
Hmm.
Okay, sorry. Continue. Pretend the last 10 minutes never happened.
Mm. Oh, I used dots, right? My
Oh,
like
suddenly there's a dot. Okay,
yeah.
great. Congrats.
Woohoo!
So yeah, the looks like you use your same solution as last time, but the difference is that you have the
Yeah,
Sentinel.
like it's the only difference, right?
Yeah,
I
yeah.
think.
Interesting. So there's another way of solving this. Another way of solving this is to accumulate the previous node,
Hmm.
and then when you have the
Okay.
previous, you can just mutate the previous.
Hmm.
Like when I demonstrated with the C++ code last time, that's what I did. I had a previous node, right? I don't know if you remember
Yeah,
that.
right, yeah.
So that's an example use case of an accumulator where the accumulator is not the answer.
Oh,
Uh, Either works, but I would say the disadvantage of this is you need tail rec. Oh, okay. So you're not gonna know this yet, but when you recur, right, you're adding to the stack, but you only have a limited number of stack space before you run out. Yeah, no,
okay.
I'll save this for next time. I'll explain this next time. When we get to C++, I explain it. Which is why sometimes the solution where you use the accumulator is preferred.
Okay.
Okay. All right. I'll give you the. Oh yeah, actually, I wrote the next problem last time. Let me copy it down.
Really, really. Hmm.
So I'll get you. So this is probably our last session on this topic. We're gonna move on to a new topic next time. So I've pasted a new task at the bottom of the file.
Okay. Create take and that mutates the given list such that only the first n elements are preserved and produce the list that has the remaining elements. Create chop and that mutates the list such the first n elements are removed, produce the list that has the removed n elements. Uh, you always give me like impossible tasks.
This is not impossible, man.
Mm, okay, okay. It shouldn't be like that hard, right? Uh, okay. I must like. Can you see like what I'm writing? Wait, wait. Okay, okay,
Yeah, I can.
okay, okay. So function take n, right?
Yep.
Given first n elements. Okay, and it just will I be okay? Will I be needing? Uh, yeah, I think so. Mm, the return also. Right, right. Mm, the the remaining elements means that the elements that are preserved, right?
No, the other half.
The other
So
okay, okay.
yes, this differs from
So,
the previous in that a different list is being produced here.
uh, hmm. Ah, hmm, hmm,
So let's start
hmm.
with the tests.
Of course, of course.
Yeah.
Uh, so like, uh, can I use the same list? I suppose I can.
Hmm?
Uh, okay, so meaning of A is take of uh, I don't know, like node one and uh two. Two should be like um, so like okay. Okay. Wait. So this should return. Okay. I actually that is great. So it should equal to like uh nodes three, right?
Okay,
Is
is Node 1 and Node 3 a mutable list? T.
what? Sorry?
Is Node 1 and Node 3 a mutable list?
Of course not. Of course not. What?
Okay.
Why are you asking me that? Yeah. Yeah. Uh, okay. And this uh, value should be like one, should be like three, and right?
Wait, why is line 553? Okay, there we go. Yeah.
Okay. I should like create. Mm, no, that case is good, I think. Do I like must create other cases, other tests?
I would test that the RAM A is intended. So RAM A is not a node 3, right? RAM A is a mutable lister.
What?
So what does take n produce?
Immutable list, right?
Mutable list. What is node 3?
Uh, a node.
A node. So line 548, that's gonna be wrong, right? The test will fail no matter what.
Hmm. So should it be like this?
Sure. Remember how I said there
Okay.
are like two notions of equality? The extension and
Yeah,
intentional?
yeah, but I don't know how to
Okay.
like.
So there's a special thing we need to do to fix that. For now, let's just continue. When this fails, we'll continue, we'll return to it.
Uh, hmm. Okay, okay,
All right. So I normally I'll ask you to write more tests, but again, since your focus is on competitive programming, I'll take it easy on the test for you. So let's
okay.
go to the body.
So if it equals zero, right? Our edge case, I suppose. What? I don't have that written up. It should return like everything, right? Mm.
It'll return
Hmm.
everything.
What?
You say it will return everything if n is zero.
Sh like, should it not?
No, no, yeah, yeah. No, it's just making sure that you're confident of that. Yeah.
Okay,
So that's
okay.
that's an interesting property, right? You just produce everything.
Ah, so should it be like ML?
Sure, sure, yeah.
Okay, else is else is more interesting, right?
Yes. And
Hmm. Because uh, okay, we must definitely like change uh, our 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 mutable list, right?
okay.
So like the rest should be like no. Hmm. Ah, my mind is like going crazy. I don't know what to do.
Okay. Uh, I'm going to. Should I? Okay, wait. Let me think about this. Let me think about how I want to approach this. I might
Uh,
ask you to. Have you ever used Excalibur, the whiteboard I've been using?
what?
Or do you know any whiteboard software? You know, like Excalibur. Whenever I use a whiteboard,
Yeah, yeah.
do you use any software like that?
I use like we have like minute left on this meeting, so
You have what?
we have like a minute left on the
Yeah,
meeting.
yeah.
Yeah,
Yeah, I'm
I
gonna send you a new link. Okay, I'll send you a new link now, and then we'll continue our
okay,
discussion.
okay.
Okay.
Yeah, yeah,
Okay. All
back.
right. Do you have
Uh,
any whiteboard software like the one I use? Do you have anything like that?
I I do not.
Okay,
I do not.
I'll give you the one I've been using.
Of course.
So I use excalidraw.com.
Hmm.
Uh, I will send you the link on Zoom chat. Can you open that up and share your screen with me? I'm going to
Of
ask
course.
you to do the box and arrow diagrams.
Hmm. Can you not like share me the session on the Excalibur?
Wait, wait, can you see the stuff I sent you?
Yeah.
Oh, okay, whatever. Okay, you can use that. Yeah, that's fine. Wait, so, wait, if we can see the same screen, you don't even need to share a screen. I can share mine.
Yeah,
Oh,
yeah.
shit. Oh, wait, I didn't know that. Okay, wait, where do I find you? Where are you?
Like not right now, but you have to like send me
Oh,
the link to sharing link.
I have to start a session. Oh, wait,
Yeah, you
I didn't
have to
even know
start
this.
it.
What the heck? Oh, shit. Oh, shit.
I even have the site in Polish.
What the hell? Okay, wait, let me send you the link again. What the? I didn't know you could. Dude, this is game changing. Oh, dude, I can use this in my sessions. Oh, shit. Oh, oh, shit. Wait, how
Hmm.
do you know this? I thought you don't use this software.
I don't. I just saw like a share button.
Oh, oh man, I feel stupid now, man. Okay, okay, wait, hold on. I need to share my screen first.
Of
Uh,
course.
what the hell? This whole time?
Wait. I will
Dude,
like connect my drawing tablet.
you have a drawing tablet? Holy shit, dude, you're more advanced than me, man.
But I cannot draw, but it doesn't help me.
If you have a drawing tablet but you don't draw, that could only mean one thing. There's like a
Mm.
game there, like people you also do you play
Of
Osu?
course, of course,
I knew it, bro. Dude, that's what it means. Like people have a drawing tablet but they don't draw, right? Okay, yeah, they play Osu. Okay, where are you? Where do I find you?
wait, I need to. Okay, I'm back. I'm back. Okay. Mm.
You, you can find all the stuff I've been doing with everyone else.
Really?
Yeah, I mean, we can see some of the stuff we did a long time ago. I've not created a new session ever since I
Mm.
started this.
I actually have like different whiteboards, but not on Excalibur, and the buttons are really different, so it messes up my mind. Okay, where are we at? Here, right?
Should we go to the right of where you're
Yeah,
at? It's
yeah,
just where the empty space. You can see me, right? Where?
yeah, I can see
Okay.
you.
Okay, I would like you to, can you create a box and arrow diagram of, let's say, the M list 1, 2, 3?
Mm, can I just copy like what you have write it? Is
Uh, I will
or
only allow you to copy one box because I want you to have the
mm,
exercise of working through everything.
of course.
Yeah.
It doesn't copy the box. Of
Oh,
course
you
it
need to
doesn't.
like highlight a little bit over, yeah. You can take the arrow too, that's fine.
Okay, okay.
Yeah, yeah.
Yeah, of course I need to select.
Okay.
Wait. The drawing tablet is not really helping me. It's
Yeah,
I
cause
just
you're not
I
actually drawing,
disconnected
right?
it. I disconnected it.
Okay.
Okay. So like okay. Mm. we have our sentinel right at the start,
Mhm.
or that, or do we? Oh, the arrows are really helping.
Oh yeah.
And
I'm
so
gonna make
like,
that blue just for consistency.
of course. Mm. Okay, and then we have data one, data of uh two, and then data of three, and it points to like empty, right?
Yeah. I'm actually gonna color this something different. Let's say orange
Uh,
or yellow. Yeah. There we go. Okay. So let's say we are taking the first two. So let's say take n at where n is 2.
mm. Oh, wait,
Okay, how
wait.
would you change the like what happens to our box and arrow diagrams when we n is 2?
Where n is two, right?
And yeah, let's say
Hmm.
the user list is what they
Okay,
passed
so
in is this.
so the arrow, like, wait.
Wait, how do you do that? Wait, what? You can do that?
You're learning new things with me, right?
The heck? Dude, this is your first time using this. What the hell? How do you do that?
Uh, okay, I won't tell you. I won't tell you.
What the hell? Dude,
Hmm.
you know when I was younger, right? Like I always pick up
Hmm.
technology very quickly and old people be like, wow, young kids, they pick up technology so fast. And I'm thinking like these old people, what are they talking about? Now I understand, man.
Yeah.
Now I
Okay.
understand. What the hell?
Hmm. So like return this. Can you see like what I am selecting? Or
Yes, yes, I can.
I am paranoid. Okay. Uh, so we return this, right? Hmm.
Okay.
So
Oh, so okay. I prefer if you did this. Like just draw an arrow from return to the data tree box.
okay, okay, it makes sense.
Yes, because that's closer to how our model of computer works, right? With
Yeah.
a reference to the box. Yeah.
Okay. And the user lists. Okay, and the user list like changes, right? So
Okay.
we are like basically doing a delete add, but we are returning a different thing. If we are like, uh, if our index is the previous from last, the
Well,
right?
yeah, but remember that. Let me change the situation a bit. Let's have data 4. Uh,
Okay.
if we have a data 4, I'll do this for you.
Uh, okay, okay.
Which honestly, maybe you are actually faster than me, so maybe I should have asked you. Never mind, I've done it. So let's say we have this, and like, so for example, let's bring the arrow back like this. If we were to take first two, well, how would we change this?
Like change the first two.
So no, we're take n where n is 2. How would we change the arrows?
So like this points to empty, right?
Okay, yeah.
And return points to that.
Yeah, so a key distinction to make here is that unlike delete add, the arrow you're changing is always going to point to empty.
Mm,
Whereas in delete add, the arrow points to the current's next, the current's rest.
Okay.
Okay. Yeah, yeah.
Okay.
So that's one key distinction. I do want to say, give a key takeaway here. Key takeaway. Arrow changing in box and arrow diagram means mutation in code. Yeah. You see that?
Yeah.
So it depends how you do this, but in theory, you can solve this with just one mutation. In theory.
Hmm.
I also want to
Okay.
give, okay, I want to note one thing. You could remember whenever you create an empty, it's always referring to the same box, right?
Yeah.
So at the end of data two box, you can just create a new empty and you're guaranteed to get back the same box. You don't have to like find you don't have to go to all the way to the end of the list to find the empty.
Oh, okay, 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 okay.
Yeah. So, yeah, yeah. I knew to say this before you did all the hard work.
Wait, wait. So we just we must like find the uh, index with like our link with like the index, right? Our node with the correct index, right?
Okay.
And then change its rest to empty and return its rest. Like
Be careful though.
before changing the
Yes.
yeah,
Yeah, so what you mentioned is very important. Remember, with mutation, time matters, right?
right,
If you
right,
delete
right.
the
Yeah,
rest
yeah,
first,
yeah.
you're gonna lose access to it. So yes, yes. So
Mm.
you got it. You solved it. But I want you to do it with code now. All right. Let's get back to Visual Studio.
Okay, okay. Do we need like do we need a helper function or
Maybe. So focus on take n
oh
first. When you need one, then you can create one.
okay.
Yeah, my advice is only create a helper function once you're able to use it in your main function.
Makes sense, makes sense.
Yeah.
Uh so like okay, okay. Uh, wait, wait. If not, then we must change the list. Um, hmm. Yeah, it's so much harder to do in code.
Which is why we're doing this. So, yeah, like all the sessions in the past have been pretty easy for you, but I can tell this is something new to you. That's why it's more challenging.
Yeah, yeah, yeah.
Oh, it's okay. If you can learn the escalator, can share sessions, and you can bend the arrows immediately, I'm sure you can do this too.
Wait. So, okay, okay. Mm, Ah, mm, hmm. Like return the rest, right? No, we should like return the whole list, but I can't make it with recursion if we're returning the whole list. Oh, wait.
Okay, let's go back to the Excel draw.
Ah, yeah.
So yeah, I need to first make sure that you understand how the arrows change or like how they don't change. Then once you know that, you can
Okay.
do stuff. So let's say here's our situation. Let's say we have user list. I'm going to fix back the arrow, and return
Mhm.
list is undecided.
Yeah.
Is there a way I can? Okay, let me just move that away. Okay, so let's say we're take n is zero. What's this? How are we gonna do this?
Mm, we are okay, okay. So we are like pointing this here, right?
Okay, but can you bend the arrows again? How the
Yeah.
hell do you?
You just click the arrow and there is like a node.
Oh, dude, I'm stupid, man. Okay, all right,
Yeah.
thanks.
Okay. And that is it, right?
How about the return list?
Mm, here.
Okay, but remember, what's the type of return list? Is it a node?
Okay, okay. So, okay, so we must like create M list of this.
Okay. Can you show me how to create with the box and arrow diagram?
Hmm. Like add the sentinel.
Yeah. So yeah, whenever you want to create something, it means to create a new box, right?
Mm, right. Mm,
Nice.
okay,
Okay,
okay.
let's go back. So, excuse me. Right, let's go back
Bless
to the
you.
code. Thank you.
But no, no. Uh, M list of. Huh. Yeah. Like, right?
Okay.
You're not. You're not telling me anything.
Yeah, the test will tell you. So it's program first, the test will tell you, right? Keep going, keep going.
Okay. And then we must
So
change.
are we done here? That's it. We make M lists. That's it. No more.
Mm,
Well, in the box and arrow diagram, how many things did you change for the N0 case?
uh, two, right?
Two things, right? One of them was we create a new box. So we did that. What's the second thing?
We changed like. Mm,
Yeah.
okay. Uh, wait. Rest. Mm, should be like this.
Uh, um, oh, rest bang rest colon. Wait, why is it rest bang rest?
because first we are like referring to uh, the rest in mutable list and then the rest in node.
Wait, I thought the rest of the Sentinel should point straight to empty. Right, it's just one level, right? Yeah, okay.
Yeah, okay,
Okay,
okay.
but notice if you do this right, what's being produced here in this if block?
Mm, like the M list, the both, right?
We can only produce one thing, right? We can't produce two things. We need two things to
Yeah,
happen, but we can only produce one thing. Which is the thing we
yeah.
need to produce?
So how to do that?
So here's where we are at. We need to create the list before we change ML rest, right? But we need to produce the list we created.
Yeah.
So how do we achieve this? There is a way.
Hmm.
Okay.
Do you need to do something with something?
Uh, not with line 540, but you have the right idea. The use of variable will help you. Variable has the power of saving things, right? So you can do
Right?
something, save it, and use it later, right? So how can we use that? What's the thing we want to save here?
Like the rest, right? The ML rest.
Is line 540 the one we want to save? Remember, line 539 is the one we want to produce, right? That needs to go last. But we need to also make sure that we're creating the list first. So line 539 is correct. It needs to be there, but we need to somehow save that.
Yeah, okay. I didn't thought that we are returning it, so we are like
Yeah.
ending our program. Okay.
Okay. Line 539, we now have something. Let's not name it something. Let's name it something better. Like result is a good one. I like to use result or res. Yeah,
Yeah.
in C++ convention res for result. And then, okay, how do we use res?
Mm, like
Yes. Okay, remember this. You're going to use this a lot in the future, especially if you program in C++. The idea here that the effects of mutation must happen in a certain order, but you need
mm,
something from earlier for later, so you save that in a variable to use that later.
okay.
Okay. This is going to have an error later, as you'll soon see. Oh, actually, we are out of time.
Yeah, yeah. I
I'll
didn't
tell you the
see
error
that.
now. Line 540 and line 541 are both expressions,
Yeah,
but an if
yeah.
block can only produce one expression. There are two ways around this. I'll let you figure it out on your own. Okay, so yeah, we made pretty good progress today. If you have time, try to work on this on your own. If not, we can continue this
Okay.
tomorrow. I'm gonna save chop n for next time actually, for future,
Okay.
because I let this be our last thing, and then I'm gonna move us to a new topic. And our new topic is not gonna use mutation, so we're gonna get a break from mutation.
Okay.
After our new topic, we're gonna move to C++.
No way.
Yeah, so the next topic is this next topic is a huge topic, by the way. Even though there's no
Okay.
mutation, it is challenging in its own way. We'll we'll get there. We shall get there. All right, Simon, good
Mm.
work today. I'll see you tomorrow.
See you tomorrow. Bye.
All right, bye bye now.